Hello everyone, myself Hans. Today we are going to solve the given problem from topic integral calculus. Question is given here. Find the limit when n tends to infinity of the series. Series is given here. Limit n tends to infinity. Summation r is equal to 1 to n and n upon n plus of r under root of r into 2n plus of r. Let's solve the problem. The question is based on definite integral as a limit of sum. Here given limit n tends to infinity r is equal to 1 to n. Here n upon n plus of r, and in the under root we have to multiply with r. This gives 2rn plus of r square, and further we can also write here this is limit n tends to infinity r is equal to 1 to n, and here this is n. We can also take common n plus r. From n is taking common, this gives 1 plus of r by n, and from here in the given under root we can also take the common n here. This gives 2r by n plus of r square upon n square. We have to take under root of n is taking outside. This gives limit n tends to infinity summation r is equal to 1 to n to n is cancelled out here, and this gives 1 upon of 1 plus of r by n, and this n is taking outside here. Once again we have to taking common n square here. N square is taking common, then we have to get here 2r by n plus of r square upon n square. N square is taking outside, this gives n under root of 2r by n plus of r square upon n square. In definite integral as a limit of sum, we have to must remember the sum point here. R by n replaced with x and 1 by n replaced with dx, and summation r is equal to 1 to n limit n tends to infinity replaced with integral limit is 0 to 1. So the given series of r term becomes here, this gives, first we have to remove limit n tends to infinity summation r is equal to 1 to n replaced with integral limit is 0 to 1, and here 1 upon of 1 plus of, here r by n, in place of r by n we have to putting x, and in place of 1 upon n we have to putting dx, so we have to writing in numerator dx under root of here 2, and in place of r by n we have to putting x, and here r upon n, r square upon n square, we have to put the value of r by n. This gives plus of x square, and further we have to solve the given integral. We get the required answer. Here we have to get 0 to 1, and this is dx upon 1. We can also write 1 plus of x is written as x plus of 1, and in the under root we have to here 2x plus of x square, and here we have to add plus 1 and subtract minus 1. First we have to add 1 and subtract 1, and this gives integral limit is 0 to 1 dx upon here x plus of 1, and we can also put in place of x square plus 2x plus 1 we have to writing here x plus 1 का whole square minus of 1. When we have to open this x plus of 1 का whole square, this gives x square plus 2x plus of 1. And from here we have to let x plus of 1 is equal to t, then this gives dx is equal to dt. And we can also change the limit here. When x is equal to 0, then t is equal to 1, and when x is equal to 1, then t is equal to 2. The new limit becomes 1 to 2. Here dx replaced with dt upon 1 x plus of 1, we have to let here t, and under root of x plus 1 we have to let t. This gives t square minus of 1. And we can also here 1 taking 1 square, nothing to effect. And further we have to know the formula here. Integration of dx upon x under root of x square minus of a square is written as sec inverse of xy. So we have to use this formula here. This gives sec inverse of t by 1, and here limit is 1 to 2. And we have to put the limit here. Putting the first we have to putting the upper limit. This gives sec inverse of 2, and when we have to apply lower limit, this gives sec inverse of 1. And we know that the value of sec pi by 3, here we can also write this is cos inverse of 1 by 2, and this is cos inverse of 1. And further we have to write here, this is the value of cos inverse of the value of cos 60 is 1 by 2, so we have to putting here cos pi by 3 minus of cos inverse of the value of cos 1 is the value of cos 0 is 1, so we have to putting here cos of 0 radian. This gives cos to cos inverse is removed. Here we have to get pi by 3, and here cos to cos is removed. This is 0. So this is the pi by 3 is the required solution of the given problem. Thank you class, and thank you for watching.